Having functions that will add nodes for us in a linked list is very useful, which is why I will simplify the idea of using nodes and the code for those functions using animation so that you're able to visualize. I will also show you the code and explain it as we continue to build our linked list project. In this video, I will show you how to add nodes to a linked list, and this is the second video of the data structures linked list playlist. After this video, you will know how to add a node in front, at the back of a linked list, and also to add nodes anywhere in the linked list using an index. And after I show you what the code does using animation, I will show you the actual code for the add node functions. The code in this video is to have three functions that will add nodes in different positions of the linked list, in front, to the back, and at an index in the linked list. For example, say we want to add a node with a value of 1 in front of the linked list. Our function will do that. Same if we want to add a node at the back of a linked list. And finally, if we want to add a node at a certain position in the linked list, which we'll call an index. And for this example, if we add a node with the value 5 at an index 3. And now I'll show you how to create these functions using code. Before we dive into the code for the add node functions, let's revisit what we covered in our introduction to linked list video, which I will link down in the video description along with the other linked list videos. So we said a node of a linked list can hold data to be stored and the next node pointer, which will point to the next node. So when creating a node using a struct or a class, but we'll be using a struct, we will define the integer data variable and the next node pointer. And we create a constructor because every time we create a node, we want to initialize the data variable as well as the next node pointer, so that we don't have to do it manually in our functions. And the constructor takes in an integer value, which will be the data we want to store, and it will set the data variable we declare. And finally set the next node pointer to null, as it is pointing to nothing for now. And that's it for the revision. For more on the introduction, you can watch the intro video. We will create a function that will create nodes for us and return the pointer to the node itself where it is stored in memory. So the function has a node pointer return type, that is node star. And the create node is the name of the function, and it takes in an integer data, which will be the data we want to store, and then create a pointer n, which will hold the locations returned by the new keyword when it allocates memory for the node with the data we want to store. And since the node constructor will initialize the data variable to the data we want to store and the next pointer to null, we don't have to do it manually. Finally, we return the pointer to the node, which is the pointer n, and it is equal to 1000 in this case. Now we can continue to the first add node function, which is the add node front, which is the add node to front function. Adding a node to the front of a linked list is very easy. Say for example we have a linked list with 3 nodes with values 3, 7, and 9, and we have a head pointer pointing to the first node with the value of 3, and we want to add a node with a value of 1 to the front of the linked list, meaning in front of the head node, so that the node we are adding becomes the head node. And so we create a function that will add the nodes in the correct position. This function is a void function. We are not returning anything, and it takes in integer data, which is the data we want to store. And for this function, we only want to call another function, add node to front 1. This function will be focused on adding the node to the correct position, and this will take in the data we want to store and the head node pointer of the linked list as arguments, because we want to have the head node pointer pointing at the first node, so we can use it to access the nodes in the list. Let's look at this function. And remember, after explaining this code, I will show you how to use it in an actual linked list project. So this function is also a void function, and it takes in integer data and a node pointer as arguments. After that, we check if the head is equal to null, meaning the linked list is empty. And if that's the case, we don't have any nodes in the linked list. We want to set the head node pointer to the newly created node, which we create using the create node function as I explained a moment ago. But if we have nodes in the linked list, like we do in our example, we will create a node pointer n, which will hold the newly created node. We will set the next pointer of the newly created node to point at the current head node, and finally point the head node pointer to the newly created node, which then becomes the new head node. And that's it. We have added the node in front of a linked list. Now let's add a node to the back. Say we have a linked list with the values 1, 3, and 7, and we would like to add a node with a value of 11 to the back of a linked list. And like before, we create a function that will also be a void function and takes in an integer data and only calls another function which will take in the data we want to store and the head node pointer as arguments. We need the head pointer so that we're able to move through the linked list. Let's look at the actual function. It is a void function and takes in data and a node pointer. Firstly, we check if the linked list is empty, if the head pointer is pointing to null or nothing. If it is empty, set the head node pointer to the newly created node. If we have nodes in our linked list, and like we do in this example, we will create a while loop that will check if the current node's next pointer is pointing to null, because the node whose next pointer is pointing to null is the last node. And since we passed in the head pointer as argument to this function, then the node pointer ptr is also pointing to the head node. So in our while loop, if the pointer ptr or the current node's next pointer is not null, we want to advance the pointer ptr to point at the following node, the node with a value of 3. If the second node's next pointer is not equal to null, we advance the pointer ptr to point to the node with a value of 7. And this node's next pointer is null, so we exit the while loop, and the pointer ptr is still pointing at the node 7. So we set its next pointer to the newly created node, and it's that simple. And before I show you the complete code, let's look at the last function. Okay, say we have a linked list with the values 1, 3, 7, and 9, and we want to add a node with the value of 5 in the third position or index after the second node. We will create a function which is a void function, and this one takes in two arguments: the index or position where you want to add the node and the data you want to store. And it calls another function which takes in the previous two arguments and also the head node pointer as a third. Now on to the second function, which takes in an integer index value and an integer data value and a node pointer. We first create a pointer c, which will be like the current point or the temporary point, and define an integer x, which will help in keeping track of the position, and we set it equal to 1 because the first node is at position 1, which is where we'll start. Now since we passed in the head pointer as argument and set it equal to ptr, therefore ptr is pointing at the first node. For us to find the position to add the node, we create a while loop, which will check if we have reached the position we want, and if not, keep running until we get to that position. So if x is currently equal to 1 and not equal to the index, in our case 3, we enter the while loop and set c to point to ptr, to point where ptr is pointing. The reason we do this is that we want to leave the pointer c one step behind ptr. So we want the pointer c to trail the pointer ptr so that we have access to the previous node. We increment x by 1 and advance the pointer to point to the following node, which has the value of 3. And still in the while loop, x is now equal to 2 and not 3. So we advance the pointer C to point at PTR and increment X by 1, and then advancing PTR to point at the following node with the value of 7. And now in the while loop, X is now equal to 3. Same as our index. We exit the while loop and create our node. Now, with the node pointer N pointing to the newly created node and the pointer C pointing to the node with the value of 3. So we can access its next pointer and point it to the newly created node N. And we set the newly created node's next pointer to point to PTR, which is the node with the value of 7. And we're done. We have the resulting linked list with the value 5 at index 3. Now back to the files we created for our project. Inside the linked list.h file, the header file, we want to define the nodes, the add node functions. And the first function we want to create is the function that will add a node to the front. The function that will add a node at the front of a linked list. This function has a void return type, and we're going to call it add node to front, and it only takes in an integer data variable. And second, I want to define the function prototype of the function that will add a node at the back of a linked list. This function will also have a void return type, and we'll call it add node to back. It also takes in data, integer data. Finally, the last function, this will be the function that will add a node at an index of a linked list. Now this function will take two parameters. It will take in an integer index value and an integer data variable. And the data will be the data that we want to store. Now we will create a private section for our class. And we want to define a few functions. A void function called add node to front 1, which takes in integer data and a node pointer. And another one called add node to back 1, which also takes in integer data and a node pointer. And the last one, which is also a void function called add node. It takes in integer data and an integer index value, and finally a node pointer. And now we're done for the header file. Now going on to actually writing out these files in the linked list.ccp file. But first we need to define the size of a linked list, and we set it equals to 0. And we also need to define it inside the linked list.h file, because we'll need it in the moment when we are defining the function. The first function that will add nodes to the front takes in integer data and only calls another function, the add node to front 1 function, passing in the data and the head pointer. Now when actually defining this function, the add node to front 1, which is also in the linked list file, the linked list class, takes in an integer data and a node pointer. Now this function will do the actual adding of the node. So I remember that we forgot to create a function that will create nodes for us, because we will need that function to return the pointer to that newly created node so we can access it and link it to other nodes. So this function has a node pointer return type, and we need to define it first in our linked list.h file. So it has a node pointer return type, and we'll call it create node, and it only takes in an integer data. So let's create our create node function. It takes in data, and for this function we want to create another pointer n and set it equal to the new keyword that will create the new node for us. Now that we have then the pointer to the newly created node, we don't have to set these values manually. We don't have to set the data variable and the next variable for the newly created node, because we already done that in the constructor for the node. So now we only need to return the endpoint to that newly created node. And now we can continue with defining the add node functions. So back to the add node to front one. Here we need to check a few things. If the head pointer is equal to null, meaning that the linked list is empty, we need to set the head pointer equal to the newly created node, which we'll create using the function we just defined. If we have nodes in our linked list, then we want to create a new pointer n and set it equal to the newly created node, which will be created using the function create node, and we want to set its next pointer to the head, and then we want to set the head pointer equal to that newly created node, and then we increment the size of the linked list. And that's it for the add node to front function. Now, adding a node to the back of a linked list. This function will be also a void function, add node to back. It also takes in an integer data, and like the first one, it also calls another function, the add node to back one, passing in data and the head pointer. Now let's actually define this function, add node back to one. If the head pointer is equal to null, meaning that the linked list is empty, we want to set the head node equal to the create node function, which is the newly created node, passing in the date. But if we have nodes in our linked list, we will enter the else statement, and the while loop will check if the next pointer of ptr is not equal to null. And if it's pointing to something, we want to update the pointer ptr to point to the next node. And when we find the last node, we want to set its next pointer equal to the newly created node, and then that node will be added to the back of the linked list. Finally, increment the size of the linked list. Now, adding a node at an index of a linked list. We also define this function, add node, takes in an integer index value and an integer data. Now this function will call add node 1, passing in the index and data and the head node pointer. Let's define the function add node 1, which is also in the linked list class. Takes in an index, a data, and a pointer. Now for this function, we need to check if the index passed into the function is in the range of the linked list. So if the index is less than 1 or the index is greater than the size of the linked list plus 1, then the index is outside the range of the linked list. So we want to print out invalid index. But else, if the index is valid, we want to create a pointer c, which will be like the current pointer, and an index and an integer x, which will set it equal to 1 because the first node is at the first position is equals to 1. While x is not equal to the index we're looking for, set the pointer c equal to the pointer ptr, and then increment our counter variable x, and then update the pointer ptr to point to the next node. When finally we find a node, and finally when we find our index, we want to create a node pointer and set it equal to the node we want to create, and set the pointer of the node previous to the index we want to add the node to, set it equal to n, and set the pointer of our node to the next, and finally increment the size of the linked list. In our main.ccp file, we want to create an instance of a linked list. We will call it my list, and we will test our functions. First, we'll add a few nodes to the linked list. We'll add a node with a value of 3, 5, 7, and 9. And we also need to add nodes using the other functions. So we'll again call the myList linked list and add a node at index 3 with a value of 6. And we also want to add a node at the front of the linked list with a value of 1. And we return 0 if there are no errors. Let's print out a statement that says all nodes are added correctly, so that we can see if all these functions are working correctly. And it seems like we have an error in one of the functions we created. So now we have to go back to the linkedlist.ccp file where we wrote our functions. And we need to fix the error we made in the header file. We forgot to put the 1 for the addNode function, addNode 1 in the private section of the class. So again, we compile. In order to know how to add nodes to a linked list and have a solid idea of how they work, we can now move on to discussing how to print the linked list, so we can see all of the nodes we added to the linked list. And please just take only 10 seconds to click the subscribe button and the bell, because it helps me to grow this channel and you won't miss any videos that might help you in the near future. Thank you for staying with me until now. And you can support me by checking out my Patreon page. The link is in the description. And welcome to ACoreFundamentals.